Alright, 2.4 is going to be about solving and graphing compound inequalities, which are very similar to our simple inequalities. We just have one extra thing. So we're going to solve and graph them very similar to what we did in the last section, and then we'll have one more section after this. The first thing we need obviously is our definition of a compound inequality. That's going to be an inequality formed by a union, meaning you're going to see the word or in the statement. Or it's also one formed by an intersection, meaning we use the word and when we describe it, and it's a combination of two simple inequalities. So an and statement that makes sense would be something like this. This is an intersection. When we read this, x is greater than or equal to 2 and x is less than 7. So we kind of read that in a different way than we may be used to. The other option is our or statement, and we will read this one. So again, this is a union or an or statement, and we see the word or here. X is greater than or equal to 5, or x is less than -8. So here we're kind of satisfying one or the other criteria. Here we need to satisfy both criteria at the same time. Okay. Moving on then, solving a compound inequality. A solution is going to be all numbers that satisfy both pieces of the inequality, or we can even add to that one piece. So examples of some numbers from that first one that we had. If we chose a number like 5.6, this is both greater than 2 and less than 7. So 5.6 would work. One that would not work would be 8. Even though it's greater than 2, it's not less than 7, so that one wouldn't work. Okay, here we only need to satisfy one or the other pieces here. So an and statement has to satisfy both, an or statement satisfies one. So we could say 6 here because that's greater than or equal to 5, even though it's not less than -8. We could say -16. That would work because it's less than 8. What we couldn't say is something like 2, where it's in between them, because it is not less than -8, nor is it greater than 5. So 2 will not work. And then if we're going to solve a compound inequality, so like we said, we have two kinds. We have and inequalities, and we have or inequalities. We're going to solve them just like a simple inequality. And we're going to do inverse operations to all sides. Now remember also that if we have a division by negative, your symbols still switch. So that rule still stays. If I solve what we have here, then I'm going to add 6. So when I say all sides, really it's like if we have an equal sign, it's kind of like we drew two lines here. We have 1, 2, 3 sides. I'm going to add 6, but now I need to actually do that to 3 different sides. So I'd end up with 4x in the middle is less than 10 and is greater than or equal to 8. And now I divide by 4. Again, I need to do that on all sides. So I'm going to end up with, so I'll end up with x is greater than or equal to 2 and is less than 2.5. That would be the solution. So that means any numbers between 2 and 2.5 will satisfy this equation and we'd be done. Now an or inequality, on the other hand, we still are going to solve it just like a simple inequality. We're still going to do two inequalities to solve, and we need to do, could be same or could be different operations. In this case, if we divide by 5, we're going to have that x is greater than 3.2, or if we divide by 5, x is less than or equal to 2. So you see these are two different options, two inequalities to solve. We shouldn't necessarily end up with the same number. And finally, to graph a solution. So again, if we are having an and inequalities, we're going to draw a number line, just like we did last time. We're going to choose open or closed circles. So remember, an open circle means that we had less than or greater than, and a closed circle means we had less than or equal to or greater than and equal to. And finally, we're going to shade the shared section accordingly. Now, almost always, that means it's between the points. So if I draw my number line here, and before I do that, we're going to go back and find, so that was the example we had on the last one. I'm going to draw my number line here. Oops, let's see. There we go. Okay, and I'm going to label it accordingly. So I'm going to say, let's put 0 right here just as a reference. Then we're going to have 1, 2, and 3. And we don't really need to go past that or lower that. At 2, since we have the x is greater than or equal to 2, that tells me I'm going to put a closed circle here. And at 2.5, since it's strictly less than, I'm going to put an open circle there. And we want to shade the values that are between those two. So shade the shared section means I'm going to color in between those two dots, making sure not to fill in that circle. That would be how we graph for an and inequality. For an or inequality, same idea, draw a number line, choose open and closed circles, same criteria as above, and then now we're going to shade the unshared sections, meaning not between. So now we want not between the circles. So using our same example as the last one, and I'm going to set this up again, put our number line, I'm going to put 0, and then I need 1, 2, 3, and I'm going to put 4 in there as well. So greater than 3.2, so I'm going to go about where 3.2 would be and put in open circle. Less than or equal to 2, go to 2, and I put a closed circle. And now I need to shade accordingly, so it's not between the points, meaning we don't want to go in here. That would be our and statement. Less than or equal to 2 tells us to shade all of that and keep going. Greater than 3.2 tells us to shade this way and keep going. So big thing there, remember, if we divide by a negative, we still need to switch signs or switch your symbols around. Or statements, we shade the opposite ends, so we're shading the opposite ends pointing away from each other. And an and statement, we shade on the inside. Don't forget your open or closed circles depending on if we include the value or we don't include the value. So next time we will practice solving and graphing some of those inequalities, and then we'll also focus a lot on writing compound inequalities to model situations that we have. See you next time.